Uh, in this numerical, you are supposed to take one care. Once you find out all the forces, this is I'm talking about the identification of member forces of truss. In this, you are supposed to be careful that after finding out all the necessary forces, tension or compression, whatever may be, those forces are known as axial forces, axial force. Okay. After identifying all these axial forces, you are supposed to draw the complete figure representing all the axial force values in each and every member. By this, what I am trying to say is, finally you are supposed to draw this figure. Okay, this is the given numerical, and in that you have this hinge, and this one to be roller support. Then you have the notations A, B, C, D, and E. You have forces, and with the help of these forces, you have identified several internal forces. Internal forces in the sense the axial forces, right? So, by my calculation, I am getting these values. So, I will be representing the values with the help of these arrows, which will represent the tension or the compression force accordingly. Okay. So, this is the direction of the arrow for this member AB, right? And what is that? I am getting this to be 83.715. You are supposed to write down one note. All forces are in kilonewton and dimensions in meter. So that by writing down this note, what you are doing, you are not repeating this kilonewton value everywhere. Once you have written this statement, that means it is true for all the values. Then for member AC, I am getting this value to be 41.857. So see the representation of these arrows. Let's say, for example, I have found out the value of force in member AC to be 41.875, and the direction of the arrows are like this. So, what nature of the force do you observe in member AC? Whether it is compression or tension? Yes? Tension force, isn't it? Similarly, for member BC, the value is 37.526, or let me say 53. For member CD, I am getting this value to be 31.76. 31.76. Then member CE, I am getting this value to be 47.70. 47.74 rather. For member BD, this comes out to be 60.60. And for this member DE, this value is 83.49. 83.49. Okay. So these are the values. And finally, you are supposed to represent all these parameters, all these values in this final figure. This is essential. This is essential. This final figure is essential. Okay. So this will complete your numerical. What you have done, you have used method of joints. First of all, method of joints. in order to calculate the axial forces. Once you have found out the axial forces, then you have represented all the axial forces in this final figure. Okay, so this has to be remembered. ठीक है. Now we will take up one more numerical. So before this, before I discuss the numerical, second numerical, you should make one note that at a joint which is subjected to action of three members, okay, action of three members, but not external load. If two of the members are collinear, the force in the third member must be zero. Okay. Meaning of this statement is sometimes what you say, what you will observe rather, you will see that there are members in this manner. Let's say this is member, let's say A, B, C. Okay. So these are two members, member AB and member BC. From here it is very clear that members AB and BC, they are collinear, right? And in case if there is a third member which is attached like this to the member AB and BC, we call, let this be BD. Okay, such is the member. So according to this statement, what it says that if two of the members are collinear and the force in the the force in the third member must be zero. Okay, that means at this joint B, two members BA and BC, they are collinear and there is no external load which is attached at point B. Then force in the member, that is this third member, which is BD, this should be equal to zero. This is a rule, okay, that can be found out with the help of mathematics, but this is a general observation based on the mathematical formulation itself. And whenever you come across such kind of situation, in that case you are supposed to mention like this, that is, if two members are collinear and if third member is getting attached at the point, and if there is no load, in that case the force in the third member is zero. So we will verify that and we will utilize this statement in our further study. Okay. Similarly, if at all, for example, such is the situation, okay, if this is a part of truss like this, right, something of this sort. I have not drawn the complete figure, but in case if such is the situation, and these are the notations, for example, this is A, B, C and D, let's say. So in this, AC and CD, these are collinear members, isn't it? And over here, this at this point C, you can find that there is some load which is getting attached. Let's say 50 kilonewton load is attached. Okay. So the situation is very close to this, but over here, since there was no load, zero load, therefore force in member BD is zero. If such is the situation, and now see how, if I try to draw the free body diagram associated to this, let's say this joint C, okay, and joint C, you have got BC member, then this CA member and CD member, like this, okay. So let me consider force in member AC, force in member, let's say BC, force in member CD. This is 50 kilonewton. If I apply equation of equilibrium, that is summation of force in y direction equal to 0, what do you observe? Force in member BC will directly be equal to 50 kilonewton, isn't it? Right? So we can frame a statement like that: the members CA and CD are horizontal and they are collinear, whereas member BC is perpendicular. 50 kilonewton load is acting at point C, which is acting vertically downward. So in such case, the force in member which is attached to these collinear members at this point where the load is acting, force in member shall be equal to the load at point C, at that particular point C, and it should be vertical in nature, right? So we will come across such situations, and if the amount of the numerical wherein you will find more number of forces are given, in that case, if you find such situations and if you apply these conditions, then it becomes very easy for us to solve that numerical. Although it will look like more number of forces are acting on the truss and there may be more number of unknowns, but by using such situations, we can eliminate most of the unknown parameters and we can say that yes, using these conditions, we can identify the unknown values. So let us try to use this knowledge and try to solve the numerical. So for example, you are supposed to compute the force in each member of the truss as shown in figure. So this is member, another member is like this one is like this. Okay, this is vertical member. Okay. There are forces, and before that, these are the support conditions. Hinge at this point and roller over here. This is point A, point B, C, D, E and F. These are the point loads, you can say. "15 units, 20 units, 15 units, this is 10 units, and this is 15 units. This is 400 Newton, 200 Newton, okay. This is 1200 Newton, 600 Newton. This is point B, huh? B. So you are supposed to compute the force in each of the members. How to proceed? First of all, see the boundary condition or the support conditions, and in this it is very easy to identify the reaction forces at points A and F. Why? Because over here there is one unknown, here there are two unknowns. Am I right? This will be reaction force at A, vertical reaction force. Over here, RF vertical, RF horizontal. Isn't it? Is this okay? Yes? Yes, sir. Okay. Then, in such case, where the available equations of equilibrium are 3 and unknowns are 3, we can make use of those equations in order to calculate these unknown reaction forces. So find out summation of forces in x direction equal to 0. I don't think any kind of horizontal force to be acting on this truss. So therefore, RFH will be equal to 0. Summation of forces in y direction equal to 0. How many forces? So RA plus RFV minus 1200 plus 400 plus 200 plus 600. ये बराबर है क्या जो मैंने लिखा? Okay, equated to 0. Then summation of forces, rather summation of moment about, let's say, point F, equated to 0. So RA into what will be the perpendicular distance? I'm taking moment about point F, 40. Then minus 400 into, will it be 25? Okay. Then similarly minus 1200. I'm writing down minus because it will create anti-clockwise rotation. Okay. Minus 1200 into again 25. Then minus 600 into 10, minus 200 into 10. Anything else? Equated to 0. From here you will get RA value. Once you find RA value, you can also get RFV value. Please let me know these values. How much is RA value? Is it 1200 Newton? Please verify. And this will also be 1200. Yes, it's 1200. Both of them shall be 1200 Newton. Okay. Now see, in this numerical, nothing is mentioned, as in which method has to be followed. Since I have told you there are basically three methods, but analytical methods are only two: method of joints and method of section. So you are free to make use of any of the methods unless and until it is defined. Now, since we have started with the method of joints only, so we will utilize the method of joint concept over here, and let us try to identify the forces in each member. Okay. So we will go step by step. Before using the method of joints, just try to identify what will be that joint wherein the number of unknowns are less. Okay. 1 minute. So let us try to identify. What do you think about joint A? At joint A, how many knowns are there? This is known RA you have just found out. And other than RA, the force in member AB, force in member AC, these are unknowns. But there are only two members which are actually connected at joint A. So it will be easy for us to identify the forces in member AB, AC. Or you can even think of joint F. It is one and the same case. But let us start with joint A. Okay. Let's see. Joint A. Let's draw the free body diagram. So FBD. So this is joint A. These are the members. This is the force, reaction force, whose magnitude came out to be 1200 Newton. Initially, you assume tension force to be generated. So this is your initial assumption. Later on, you can identify the exact direction or exact force. So let me consider this to be force in member A, B. Force in member A, C. Okay. Now the only thing is to identify this angle. So can you please let me know what will be this angle value? This angle is nothing but this angle or this angle. Tan inverse of 20 by 15. How much does this come out to be? Yes. What is the value? 53.1. 53.13. 53.13. Okay. So make use of equations of equilibrium. Summation of force in x direction equal to 0. So you can say force in member AB cos 53.13 minus force in member AC equal to 0. There are no other forces than this. Then forces in y direction equal to 0. Force in the member AB sine 53.13, which is positive, plus 1200 equal to 0. So FAB, this will be minus term certainly. How much does this come out to be? Yes, please find out fast. Is it 1500 1500? Yes. 1500 Newton. That means since this is negative, that means this is 1500 Newton compression. Am I right? Hello. 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 काही नाही आपण त्यानंतर लेक्चर सुरू त्यानंतर आम्ही हाँ. So FAB, force in member AB is 1500. So this is okay now? Compression, okay? Since we have initially assumed this to be tension, but it came out to be compression. Similarly, you please find out force in member AC. कितना आता है? Please calculate it fast. Now, while calculating force in member AC, make sure that whatever value you have obtained over here, considering these arrows or these directions, you are supposed to substitute that value itself. कहने का मतलब है ये देखो माइनस एफ ए सी रादर अब यहाँ पे माइनस 1500 cos of 53.13 minus FAC equal to 0. कितना आता है? Sorry, this is not minus. This should be plus. Nobody told me. This is plus, isn't it? Because FAC and FAB cos, these two are in same direction. Okay, so this will be plus. Okay? I made a mistake over here, but now this is plus, right? So because of this, force in member AC, I am getting this value to be 900 Newton, okay? And since this value is positive, that means this is tension or whatever we have assumed for FAC, that is okay. Okay? This is 900 Newton tension. Then similarly, what you can do, you can go to another joint. After finding out all these values, you can go to the next joint. What is that joint? Can I consider joint B? Yes. Can I consider joint B after solving for joint A? Let us try. How many forces do we observe? There are three members actually, this, and this. Out of that, you can see that we have already evaluated force in the member AB. Force in the member AB came out to be compression. Okay, compression in the sense direction of the arrow shall be in this manner. Do you agree? This will be the direction of the arrow. Okay. Force in member AB. This was 1500 Newton. Okay. Then this member BC, this is perpendicular. Member BD is inclined, and let me assume this to be tension, and over here again tension. This is my initial assumption. Then there is one force which is of 1200 Newton which is acting. Correct? These are the forces. Resolution of the force. Okay. So this is joint B. And what I have drawn FBD of joint B. You know this angle. This is 53.13. Okay. So I can write this component to be 1500 cos 53.13. This is force in member BC. This is force in member BD. FBD. You please calculate this angle. Can you please calculate this angle and let me know what is this? This angle. For that, what you can do, you can drop a perpendicular from this point D on this member. Okay? So you can get this angle. तो ये कितना रहेगा? Will this be 5 unit? That means from here to here. From this point to this point, this will be 5 unit. Am I right? Because this is completely 20 and this is 15. So this will be 5, and this is 15 unit. So from here, you can definitely calculate this angle value. Can you please let me know this angle? Please calculate, all of you. Please let me know fast. How much? 18.43. बराबर है 18.43. Is it okay? ठीक है. So this will be 18.43. So I will say cos of 18.43 because this will be alternate angle. So 18.43. This is sine 18.43. Correct? Now make use of equations of equilibrium. Very simple. This is sine component 1500 sine 53.13. Okay. So over here, what I have done, I have modified this to this. Therefore, the direction of the arrow is opposite. Then summation of force x direction equal to 0. 1500 cos of 53.13 positive plus FBD cos of 18.43. That's it. Equated to 0. Summation of forces in y direction equal to 0. 1500 sine 53.13 positive minus 1200 minus FBC minus FBD sine of 18.43 equated to 0. Then I pen. From here, what you can say, you can find out first of all FBD. FBD कितना था फट से बताओ. FBD don't know take direction. Let me know the value for FBD from this equation. Let's say 1. जल्दी बताओ. This will be minus value. Are you getting it to be 949? Please check. Very simple calculation. I am getting it to be 948.6. Please, you can verify. Then you can substitute this value, whatever value you have obtained. See, this value is obtained from the directions which we have assumed. Okay? The interpretation of this shall be, this can also be said 948.66 Newton. Here we had assumed tension initially, but it came out to be negative value. That means this is compression force. But while substituting this value in the equation which are formed based on the assumed direction, that value has to be substituted and not this revised one. Okay, so you are supposed to substitute minus 948.6 in equation number 2, and from here you will get the value of FBC. FBC, I am getting it to be positive value, and it is coming out to be 299.91 Newton. That means it is tension because we have assumed FBC in the in this direction, or it will carry tension. This is what we had assumed, and this came out to be positive. However, force in member BD, this came out to be negative, and therefore it is compression. Fine. So what we have done, we have identified or we have solved joint A and joint B. Next joint, which one would you like to consider? Please, anyone? Which joint would you like to consider? Yes. Please tell me fast. Follow. Should I consider joint D? Yes or no? Yes. Should I consider joint D? If I consider joint D, how many unknown forces do you observe or unknown members do you observe? Let's say joint D, and I will draw the free body diagram. So this is the one member, this is another member, this is perpendicular member, and this is another inclined member, let's say. Okay. We had calculated force in member BD, which came out to be compressive force. Am I right? So this is known value. However, force in member DC, this is unknown. Force in member DE, this is unknown. And force in member DF, again this is unknown. So see, there are three unknowns. And we cannot make use of equation, moment equation in this case. Why? Because everything is concurrent. So choose such a point or such a joint wherein you will find that there are minimum number of unknowns. Isn't it? Okay. Now, here I go. If I take joint C, okay, if I consider joint C, this is 400 Newton. This is the perpendicular member, which we have already found out. And this came out to be tension value, isn't it? Force in member BC, कितना था वो? Force in member BC 299.91. 299.91 Newton. Then force in member CD. Let me assume tension, and this is force in member CE. Now it becomes simple for us to find out the unknown value. So please calculate this angle. कितना रहेगा angle ये? What will be the value of this angle? Okay. So summation of forces in x direction equal to 0. FCD cos 45 plus FCE equal to 0. Then this equation 299.91, which is positive, minus 400 plus FCD sin 40. देखो कितना आता है FCD वैल्यू, फट से बताओ. I think this will be a positive value. ठीक है? This will be positive value, and our assumed direction is okay. Hence it is tension. FCD is tension value. Then FC, substitute over here. Here FC will be compression. Don't you feel so? Because this value will come out to be positive, negative. No, 1 minute, 1 minute. Hold on. Okay. For nobody told me. For joint C, this is one member and this is also one member, isn't it? So we have missed this. Okay. Okay. Although the number of members are 1, 2, 3, 4. Out of these 4 members, you can see we have already evaluated this member force. How much it was? Force in member AC 900 Newton, and it was tension force. Great. So this is 900. Okay. So there will be modification in this equation number 1, wherein you will find this 900 will be like this and then equated to 0. Because of this, FC value will be positive, 100%. Okay. So how much does this come out to be? FCE. I'm getting it to be 799.9 tension. You can check. Look, at joint D, although there are 4 members, but only one unknown is there. Sorry, only one known is there. Other 3 are unknown parameters. So it becomes difficult. Over here, it is very easy. Done? Is this okay? Okay. Now FCD is found out. You have also evaluated this FBD value. These 2 are unknowns. You can go for it. Okay, and you can find out these 2 parameters. But before that, if you try to identify the forces with respect to FBD of F, FBD of joint F. Let's see what happens. This is 0 force. We have already found out. Okay. This RFB, it was 1200 Newton. Okay. Let me consider the 2 values to be tension. What will be this angle? Please tell me. This angle. Yes. Is it 56.31? Yes, sir. Okay, so this will be FDF. Okay, FDF cos 56.31, and this is sine component. Make use of that. Summation of force in x direction equal to 0. FDF cos of 56.31, which is in the negative direction. This is negative direction. Force in member EF, negative, equated to 0. Then FDF sine 56.31, which is positive and upward, plus 1200 equal to 0. Okay. From here you can find out FDF. कितना था? Negative आएगा. I am getting it to be minus 1442 Newton. You can verify. That means this is compression. Okay. Negative. FDF. Compression force or compressive force. ठीक है? Substitute this FDF, whatever you have calculated, in this equation. No, sorry, in this equation. And you calculate FEF. How much is FEF? I think you will get 799.9. Please verify. Is this okay? Is this okay or not? Please tell me. Now see, these two values are with you. That is FCE and FEF. Okay. So let me concentrate over here. That is joint E. So देखो, these are collinear members. I need everyone's attention. Force in member CE and force in member EF. These two are collinear members, and these collinear members, they are attached with third member, which is a perpendicular member, and that is DE. Force in member DE. Also, you will find that there is one force which is attached at joint E. Magnitude is 200 Newton. ठीक है? Magnitude is 200 Newton. From here, okay, from here it is very clear that force in member DE shall be equal to 200 Newton. Isn't it? If I apply summation of force in y direction equal to 0. This concept, with the help of this concept, FD will be equal to 200 Newton. And now see, in this case, in joint D, actually we were having two known values. That is this, and second one is this. Even if we would not have, even if we would have considered joint D after solving joint B, then also we had this, condition, which was over here. And based on this condition, it was very much clear that the force in this member DE was 200 Newton. Okay? Even if we would not have solved this joint F, based on our knowledge, okay, earlier discussion, we would have said that yes, these two are collinear members. So force in these members shall be same, as you can see over here. And the third member, which is perpendicular to it, moreover, some load is getting attached at that point. So force in this third member, the perpendicular member, shall be the same value as what is the magnitude which is attached at this joint E. Okay? So this will be 200. Okay? So this is how you are supposed to identify the different forces in member depending on different situations. Over here, you may argue that these two are again collinear members, AC and CE, but why we have not considered the same situation over here, and why we did not find out the value or the force in member BC to be 400 Newton. It is very simple, because at this joint C you can see, in addition to this perpendicular member, one more member is attached. So the force will get distributed, and therefore we cannot make use of this situation or condition. This is very specific condition. Okay? Is this okay? Tick. So I will stop over here, and we will discuss few more numerical in the next class. And before ending this, before solving all these things, what you are supposed to do, you are supposed to mention one complete figure, and in that you are supposed to identify all the forces, just like what I have done in the earlier numerical. Okay? So thank you very much.
Thank you, sir.